We've done a couple of videos previously which demonstrate the formation of alkyl nitrites. They're useful compounds because they're part of the only real ODC pathway to azides. Today we're going to try something different. Instead of using a nice simple alcohol like isopropanol or butanol, we're going to see what happens with a multifunctional alcohol. And the most ODC one of these is glycerol. It's a propane 3-carbon chain with an alcohol hydroxy group on each of the carbons. So here's our starting material. 10 grams of glycerol weighed out into a beaker. If you're not familiar with this stuff, it's a viscous syrupy liquid and you're better off weighing it than trying to measure the volume. And I know what you're thinking, let's nitrate it and make nitroglycerin. No, you're not. And we're not going to either. Quite often glycerin also contains a lot of water, which is also going to stop you from making anything too nasty with it. But in this case it shouldn't affect things, so go ahead and try this reaction out with your mom's expensive French facial serum. Your ass will end up looking like nitroglycerin exploded on it in any case, so you can enjoy at least part of the authentic experience. We've got 3 hydroxy groups on each molecule of glycerol to potentially react. So we're going to use the stoichiometric amount of sodium nitrite. Here's 24.7 grams. We may not get complete reaction, so this is probably overkill, but let's see. To convert our nitrite into nitrous acid, we're going to use some concentrated hydrochloric acid. We'll use the stoichiometric amount again, so here's 31 mL of 36% acid. Okay, that's the lineup. So let's get cooking. Actually, we're going to get freezing, because this reaction only works at low temperature because the nitrous acid formed is unstable. We're going to do the reaction in a 200 ml beaker, and we've got a nice big stir bar in here because having good stirring is also really important for these reactions. First up, let's get the glycerin into the beaker, and we'll wash with about 15 ml of water just to make sure we've got it all transferred across. And next we'll get a couple of ice cubes in, to cool it down, and start stirring. And now we add the sodium nitrite to the mixture. It probably won't all dissolve at this stage, but that's okay. Let's transfer our hydrochloric acid into a convenient container so we can add it very slowly. Okay, well, you know what happens when you add a strong acid to a nitrite salt. You get nitrous acid formed temporarily, which is very unstable and breaks down into water and oxides of nitrogen. Let's prove that. Even though we're adding slowly and under the surface of the liquid, we're getting a lot of brown fumes starting to form. This has to be really cool to work. So here's a bigger beaker containing some ice and a little cold water. And we'll chuck in some salt crystals. And now our reaction beaker in this. The salt and ice should together get us to below -10 degrees. So let's add the acid. First though we'll dial up the stirring, and we know some toxic fumes will be produced. So cover your ears. You can start to see a turquoise blue color forming in the beaker. This is the color of the intermediate nitrous acid forming. Even at the low temperature we've got a fair bit of nitrogen oxides produced, and so it's unlikely that this reaction is going all the way to completion. Okay, let's skip through the boring bit. Addition of the acid took about 30 minutes, and here's the deep blue resulting mixture. A lot of NO2 coming off as you can see, which is unusual at this low a temperature. And there's something definitely green and emulsion-like in there as well. Green blobs on the top and on the bottom. So our reaction looks as though it has delivered us some result. Let's allow this to warm up a bit and then see what we can do next to work this up. Well, the blue is disappearing, but there's still a lot of nitrogen oxides coming off the mixture. Maybe this stuff is unstable and decomposing before our eyes? So let's see if we can separate. Here's our trusty separating funnel. Holy smokes, that's a lot of NO2 produced as the liquid warmed up on going into the funnel. But we've got a nice bottom layer of something really pretty indeed. An emerald green immiscible oil. Let's first add 200 ml of cold water and we'll see if the change in density makes the droplets on the top of the mixture sink down to the bottom. Yes, it did. But it also resulted in a lot of nitrogen oxides produced as well. Call me paranoid, but it looks like the amount of product just decreased. So let's get this out quick. Our emerald liquid seems to be pretty unstable, especially at room temperature, and the color is starting to fade in the beaker with brown nitrogen dioxide being produced. It's not viscous like the starting glycerol was though. There's 2.2 grams here, although we suspect that the original reaction mixture contained a bit more and some of it has decomposed as it warmed up. Okay, let's take a risk. Let's try to wash it and remove any acid using bicarbonate of soda solution. This is what you'd normally do with an alkyl nitrite, as acid conditions make them less stable and decompose faster. Shit. So much for washing. The product totally decomposed within seconds in the bicarbonate solution and the flask is filled with brown nitrogen dioxide. It's possible that some nitrogen monoxide is also produced, as you can see the paler color close to the liquid where there is less air available to react. Sometimes that's just how the cookie crumbles. There's a product which we suspect could be a variety of glycerol nitrite isomers, but it's much less stable than regular alkyl nitrites and not extractable in the usual way. We could try extracting from the ice-cold mixture using DCM, but the problem then would be distilling off the DCM, which will almost certainly decompose the product. For now though, this experiment is over. We'll report back if we try again with any way to extract or purify the product, and if we learn anything about its properties. Let us know as well if you've tried this. Thanks for watching, and stay tuned.